Let's answer part A. Here we are given that the amplitude is 1 million and we have to determine the magnitude of the earthquake. So I'm going to use this relation between the M and A, which is given as M equals log A. This is log A to the base 10. So we plug in A equal to 1 million. First, we write down this A equal to 1 million in terms of powers of 10. We know that 1 million equals 10 power 6. So I'm going to plug in A equals 10 power 6 into this. So therefore, this becomes log of 10 power 6 to the base 10. And now using the properties of logarithms, we can bring this power in front, and so we can rewrite this as 10 times of log 10 to the base 10. And we know that log 10 to the same base 10 and this equals 1. This is according to the property of any logarithm, that is log a to the same base a equals 1. So using this property we see that this log value is 1. So therefore we can say that this is equal to 10 times of 1 and this equals 10. So we found the m equals, I'm sorry, this has to be 6. When we bring the 6 in front, this is 6 and not 10. So I'm going to replace this as 6. So this is also 6. So finally, m equals 6 when a equals 1 million. Let's answer part B. Here we determine m when a equals 2 million. So first, let me write down this 2 million as 2 times of 10 power 6 because 1 million equals 10 power 6. So we can write down this as 2 times of 10 power 6 and we have to determine the m. So let's use the formula for m. M equals log a to the base 10 and we will replace a by 2 times of 10 power 6. So therefore this becomes a logarithm of 2 times of 10 power 6 to the base 10. Now using the properties of logarithms, we can rewrite this logarithm as log 2 base 10 plus log 10 power 6 to the base 10. And this we write down according to the formula, that is log a times b to some base c, and this we can rewrite as log a to the base c plus log b to the base c. That is, if we have to find the product of, if you have to find the logarithm of a product, and this equals the sum of the logarithms. So that is why we have written this as like this. Now we can evaluate the logarithm of 2 by plugging into the calculator. So when I do that, I get 0.3010. So I'm going to replace log 2 as 0.03010, and this is approximated here. Logs 10 to the power 6 to the base 10. Once again, we use the properties logarithm, so this 6 comes in front. So therefore, this becomes 6 times of log 10 to the base 10. We already calculated that log 10 to the base 10 equals 1. So it is 6 times 1 is 6. So therefore we have 0.3010 plus 6 times 1 is 6. And this equals 6.3010. Since we have to approximate to the nearest tenth, we say that this is approximately 6.3. So we found m equals 6.3 when a equals 2 million. Let's answer part C. Here we determine a when m equals 4. So let's substitute into the equation for m. So this means m equals 4. So I'm replacing m by 4. And this equals log a to the base 10. And this can be written in exponent form as 10 raised to the power of 4. And this equals a. This is according to the property of logarithm. That is, we can convert the log form to the exponent form as like this. So therefore, from this we can determine that a equals 10 power 4. And this means 10 multiplied with itself by 4 times. So We get A equals 10,000. So this is the value of A when M equals 4.